Okay, that's 2468 Motorway by the Tom Robinson Band. So, welcome this morning to Pythagoras 2. Sorry for the delay. It's been a bit hectic this morning. I've had to set the camera up. It's fell off. We've had all sorts of technical itches. But we're ready to go. So, without further ado, welcome to the people who are here this morning. And feel free to type in any comments during the presentation, okay, during the Pythagoras 2 presentation this morning. Okay, so what we're looking at then is Pythagoras 2. We're really looking at moving on a little bit with this now and using the concept of Pythagoras to find missing sides. But let's have a quick recap from yesterday. Okay, so here's yesterday's sheet. So what we learnt is that if we've got a right angle triangle, okay, good morning Lydia, nice to see you. Anybody else wants to make comments, please feel free. It's great to have some feedback. Okay, so if you look at the sheet at the bottom here, we see that we've got a triangle. It's a right angle triangle, so I've marked that in there, and we've got the hypotenuse and the two smaller sides. And what we do is we look at the squares of the two smaller sides, and if we add them up together, we make the square of the big side. And that is the connection that Pythagoras found. And you know, he's credited with that, but a lot of Egyptians 3,000 years ago for the Egyptians already knew this rule, but this guy Pythagoras is the guy that brought it to the forefront, and he's a Greek guy, was a Greek guy. So let's just go through this again. So we've got the small side here, a small side here in the hypotenuse. This small side, if we draw a square, find the area, 3 3s are 9 centimeters squared. We do the same for this square here. This side is 4. Okay, and to make a square it's 4 and 4 because the sides have got to be the same. So that makes a total of 16 centimeters squared, 4 times 4 for the area. So the connection is this: if we've got the 9 and the 16 and we add them up, okay, we make 25. But what we know is that this is 5 centimeters and this is 5 centimeters, and so that makes 25, an area of 25 centimeters squared, which is the same as this and this added up. So we then learn we can use this concept to find missing sides. So there's an example down here. Okay, we don't know the length of this hypotenuse side, so what I've done is I've put a square on there, found the area 25, put a square on here. You can't see it but it is there's a square. That's 12, so 12 12 is 144. So if I add the 144 with the 25, I get 169. Now 169 is not the length of this side on its own, but it's the length of the area of this side. So we need a way to find what one of those lengths is, and we use the square root to help us. And you can use a calculator. This actually works out. 13 times 13 is 169, but we can use a calculator at that stage, depending on the type of questions. Now I want to highlight something here. Both of these triangles are really quite well known. This is called a 3 4 5. So whenever you see a triangle, okay, that has sides 3 and 4, the hypotenuse is going to be 5. That's a right angle. I'm talking about right angle triangles here. I'm not talking about any other triangle. 3 4 5. So if that was 5, that was 4, we'd know that was 3. So 3 4 5 is a good one to remember. The Egyptians knew about 3 4 5 triangles, and that's called a Pythagoras triple. And further down we've got a Pythagoras triple here as well, another famously well-known triangle, 5 12 13. There are many more to learn, but these are the two ones that we know. So in an exam, if you spot that it's a 3 4 5, you can save yourself a little bit of working out because you know straight away it's 5 centimeters. Okay, that's brilliant. So on to Pythagoras 2. So very much this morning it's about using that idea to solve some questions. So I've got a nice little worksheet set up. Okay, again, due to the clarity of the camera, I'll just have to go over some of these questions with you and highlight, make them a little bit bigger, the text. x, can understand what's going on. So let's have a look at the first section here. Now these are all kind of in common. One thing I don't like about this worksheet is they haven't put the right angle on all the time, but I'm going to put the right angle on for you. Okay, I'm not going to do all of these, but let's take the first one. Okay, all right, what do we notice about all three though, and why is this a one chili? It's a one chili question, so known in the trade as differentiation there. Okay, so the reason why we've got a one chili there is because we're always finding the hypotenuse. Okay, always finding the hypotenuse. Okay, now I'm just going to raise this up a little bit. I might be able to see it a little bit better with one of my technical items, otherwise known as a box. Okay, this is where you'll be able to see the question. Okay, so let's raise that worksheet up a little bit. So there we've got my W.H. Smith laminator to help us to raise it up. That's my zoom in, by the way. Okay, so zooming in. Okay, right, so let's have a look at the first question. 6, 8 and x. So first of all we're going to find the hypotenuse. Okay, so now I might not, technically speaking, this might not be the perfect situation in terms of algebra, because we often see a squared, c squared equals b squared plus a squared, or various forms of that for Pythagoras, a squared plus b squared equals c squared, all these sort of things. But to me it makes sense just to understand the formula is square that, it makes that squared. That's all we need to know. So this is my method of doing Pythagoras. Okay, so I'm trying to find x, so that's what I'm going to put down first. X equals, alright, and then I find the smaller side. Now that helps further on if we do the smaller side. 6 and an 8. Now we know that it's always areas. Okay, so if we make the area of x, okay, area of the square on the x, so we've got to square it. X times x, 6 times 6, square it, 8 times 8. Now notice I've left that blank for a moment. Okay, because you've got a decision to make. Do we add or do we take away? So in this case, because this number is going to be bigger, we're going to add that. Okay, so that's an add, and whenever we find the hypotenuse we always add. Okay, so from there the next step is to work out these two values. Now you should be able to manage this with your times tables, which I'm hoping lots of people are working on over the lockdown. So 6 6 is a 36, 8 8 is a 64. If these are decimals, you know, you shouldn't be panicking here at this stage, because you know, decimals, you could use a calculator if it's a calculator part of the exam, something like that. So that equals x squared. So 36 add 64 is going to give us 100. And this is, a lot of people make this final error, and that final error is not to take the square root, because what we want is x, not x squared. So to find the x part, we take the square root of 100, and that gives us 10 centimeters. Not squared, because we've undone the square part with the square root. So that tells us that's it. Now I'm going to let you think for a second. Okay, good morning Alfie. Well, good to see you. Good morning Miss Massey. Happy Easter. Borodar Miss Massey. Diane. Okay, so if we go back to this question, 10 centimeters for this length here, we've got a connection here with what I was talking about earlier. So just see, I'm going to leave that for a second, see if you can find the connection. Okay, so if we go back to the original question that I said, I mentioned this is a 3 4 5 Pythagoras triple. If we go back to look at this question, 3 4 5, see the connection? Alright, 3 double to 6, 4 double to 8, so 6, 8, 10. And because they're in the same ratio as the 3, 4, 5, the rule still applies. Okay. Any questions on that, folks? Just type them in as we're going along. Alright, so this is a grade C question, so if that's all you have to do, then I don't think a grade C question, I'm not convinced that it would be a grade C question at the moment, but there's more to this than meets the eye. So let's have a look at the 2 chili, using a bit of differentiation, as we say in the teaching trade. So section B, 2 chili, okay, so the right angles here, again, a bit disappointing that this worksheet doesn't contain the right angles, but not to worry, I'll put them in. Alright, so this time I'm actually going to do this question here. Okay. So in a similar fashion now, okay, we've got the x squared and the 20. Now I'm going to go in a bit more detail with this one, but I'm going to start it off like we just did the earlier one. So we've got an x. Okay, incidentally, I'm not going to do the working out here because there's too much going on in this page actually. So I'm going to redo this question so that we can concentrate just on the working out, because there's a lot going on there and it's distracting. So just give us a second to mark this question out here. Okay, it'll be much better to do it this way, so we've got less distractions. So what are the numbers on here? We've got an x, which is what we're going to find. We don't know what that is. We've got 20 centimeters there. We've got 29 centimeters there. And this question is not to scale, so obviously I haven't measured that to be 20 centimeters, but the diagram gives us enough information to be able to answer the questions. So what do we know? We know that if we take the two smaller sides, find the area by squaring them, it actually makes the hypotenuse, the big side, area, squared area. So that's what we've learnt. Okay, so a little bit more complicated because there's a bit more arranging here to be done. Those of you who've seen my equations video, I would advise you to have a look at that. Worth having a little look, definitely. Okay, so going on to this then, we've got x squared plus 20 squared equals 29 squared. So we want the x squared on its own. So what do we need to do to get x squared on its own? Well, the 29 squared is perfectly okay, but we don't want this 20 squared. So we're going to take away the 20 squared on the left hand side. But those of you watching my equations videos last week or the week before know that we've got to balance this. What we do to one side, we've got to do to the other. So if I'm taking this 20 squared away, I must do it to the other side to even things out. So a 20 squared might take away a 20 squared, cancels, and I'm left with a minus 20 squared that side. Okay, all our teachers at the moment are trying to avoid this phrase, this shortcut, which is change the side, change the sign. That's a kind of old-fashioned one now. We've got to try and think more about balancing the equation. Okay, doing the same thing to one side to the other. Maybe further on you could perhaps use that little trick, but you've got to understand this concept first. Now I'm going to shorten this down later on, but we're down to this section here. So what we need to do now, we need to look at these two values. 29 squared, I might be good at maths, but that is tricky for me to do. So I'm going to use a calculator to work that one out. And actually, I might as well use a calculator to put it all on. 29, I'm just doing the right hand side there. 29 squared minus 20 squared gives me 441. And then really important thing at the end there is to take the square root, which basically undoes the square of both sides. And I am left, look, I've got that still in the calculator, which can handy, so I can do square root button of the previous answer. The answer button there is quite handy. So that's the square root of 441 is 21. Works out quite nicely. Now once you get good at these, you can use a little shortcut at the start, okay? If you can identify that we're actually finding a smaller side, common sense tells me that if I add these up, it's going to be too big for that. So I've got to take them away. So a little shortcut way of just, as long as you've practiced and you're good at these, a little shortcut way is to write, I'm trying to find x. I'm trying to find a small side, so I'm taking away. I must make sure I put the big number first, the hypotenuse first though. It's good practice actually to put the big number first, even for the addition ones. Square everything, put that straight in your calculator, and you get to that stage straight away. If you can identify it's a takeaway one at the start, it can save you a little bit of time, and there's nothing wrong with that as long as you're practiced. Okay, brilliant. So let's just have another look at some questions here. Okay, so I want you to focus in on this problem solving question. Okay, TV screens are measured from one corner to another. Find the size of this TV screen. It's 51 inches. It's 44.5 inches wide. Find out how tall the TV is. So the first thing on a question like this is a kind of a numeracy one really, because it's maths in context. Okay, and incidentally, if you ever do buy any TVs, it's that distance that you're looking for. Okay, 32 inches is what we have as a TV, but that's pretty small by today's standards. So first of all, a good idea is to, like we're talking about, you know, bringing out the information, separating it from the question. Okay, so we want to get that TV separate from the actual words of that question. So we need a sketch. We don't need to worry too much about the dimensions. It's a representative diagram, although my rectangle's not quite a rectangle. Alright, and we're measuring that. Now actually, although we've got a rectangle, what we need to think about here is actually we don't need all of that information. We don't need all of that rectangle. In fact, we're talking about right angles here, so I don't even need to think about that bit, and that leaves me with a right angle triangle. Now what information do we know? So it's 51 inches, so that means the diagonal is 51 inches. Okay, I can put the units on. Oh, incidentally, just going back to these questions here, it's on the other side, people talk about units. As long as you've got the units at the end, that's the important bit. This bit here doesn't have to have, working out doesn't have to have units. It's the last bit that needs to have units. So whenever you do a maths question, always ask yourself, do I need units? Right, back to the TV then. So 51 inches for the diagonal, and we've got 44.5 inches wide. Okay. So we're now going to do the working out for this. All right. So let's give the height a bit of a name. All right. So let's say that the height is a h. Okay. H for height. Can be any letter. Remember, in maths, letters mean numbers. Right. So that's the one we're going to find. And we're not going to do the shortcut because I want to go into lots of detail. Okay. So what do we know? The square of the two small sides makes the square of the hypotenuse. So we're going to go h squared add 44.5 squared equals 51 squared. Okay, so the square of the two small sides added up makes the square of the hypotenuse. So we need to eliminate, just rearrange this. Okay, and remember we can set this up so, as long as you practice, set this up so we're doing the takeaway straight away. But this helps us with, you know, knowing whether it's an additional one or a takeaway one. I'm trying to keep the equal sign, but I'm kind of made that a bit of a space there, but it's fine. Okay, sorry, no, don't go to that one. Just think about what's going on first. Take away 44.5 on that side, so they eliminate each other. So I've got to do the same to the other side. 44.5. Take 44.5. The important thing is you do the same thing to both sides. Why do I do that? I'm getting h on its own. Okay, so we need some values. So these are quite complicated. There's decimals involved. So let's use a calculator. But actually, you know what you're doing. You can put that all in one go. 51 squared. Take away 44.5 squared. Let the calculator do the work. Notice I've turned the decimal into a fraction into a decimal. Standard mode to decimal. 620.75. And that gives me h squared. Okay, so question of the day for people out there, maths fans. Okay, what do I do next? What do I do next? Type your answers in, please. You have 10 seconds. What do I do next from that point? Okay, still waiting for some answers there, maths fans. Come on. Fantastic. The square root. We have an answer. Brilliant. Thank you, Lydia, for that again. So the square root, h equals the square root of 620.75. Alright, so we use our calculator. Square root button there. Square root 620.75. And we've got 24.91. So you can see all those decimals, right? So what do I do? Where do I'm not going to put all them down, so where do I round it to? Now, I'm just got the 24 point there, okay? Now, what we're going to do is look in the question first. If it's not in the question how many decimals to do, one decimal place is usually okay. But take a look at this. Give your answer to two significant figures. Can you see that line there? So now I'm going to just write 2 decimal points down to start with, but that's not two significant figures. I'm just doing that just to show us what we need to do. So 2 significant figures. Okay. Again, I'm leaving that out there. So questions, please. Be nice to get you, Alfie, on answering that question. I want that answer to 2 significant figures. I've got quite a few maths people watching this morning. Have we got any answers? 2 significant figures. Fantastic. Well done, Lydia Rumsey. That's brilliant. So that's going to be 25. Fantastic. And well noticed, a lot of people would make a mistake here and put 24. But 2 significant figures means 2 non-zero digits. Well, it could be 0 if it's trapped, but 2 non-zero digits counting from the left to the right. 2 places there. So 2 places there. So we don't need any of this. But the 9 makes that 4 go up to 5. So that's centimetres. And that's done. So that's it for Pythagoras. Okay. The things to remember are, okay, square. The 2 short sides makes the hypotenuse squared. think carefully about, am I adding or taking away? You can use a shortcut here to eliminate some of this algebra, but am I finding a big side or small side? Am I adding the two values like in our first example today? That was an add one because I'm finding the big side, or am I taking away because I'm finding the small side? That's something to watch. Remember to square, and most importantly, square root and then round your answer. So this would actually be 4 marks in the GCSE exam, 3 marks for the working, and because it's asking for significant figures, you get an extra mark for that. And incidentally, if you've messed this question up completely and you do this last bit, no matter what numbers you put down, you make them up, and you put 2 significant figures down, boom, there's 1 mark. That's it for today, folks. Okay, so I'm going to have a break tomorrow because it's still the Easter holidays. Remember that the main work you're doing at the moment until Monday is getting up to date with all the previous work that's been set by your maths teachers. Okay, I might go live tomorrow if I have got plans, because it is my holiday too, but just keep your eyes open. I might do a little thing at 10 o'clock, possibly look at some number work, stuff like that. So keep your eyes open. Otherwise, it'll be Monday, 10 o'clock. Now, the government is still making decisions about schools at the moment, but I think the announcement will be another 3 weeks of lockdown minimum. So if that's the case, on Monday I'll be resuming my my maths live there, and we'll crack on. I'll post what the topic is onto Facebook, and if you can, pass the word around. I'm getting lots and lots of views, but later on in the day I could do with some more people being here live, so keep your eyes open for that. Okay folks, thank you for joining me this morning. It's been a pleasure.